All right. Just so you guys know, when we're done with this, and maybe when you guys are working on things, I'm gonna start sending each of you a message on Schoology that has the list of assignments you're missing from the past 2 weeks that you either need to get caught up on or finish, and I'm including the stuff that we did today. So if you have not finished the things that we started this morning, it's gonna be on that list, so just know that it needs to be finished as well. But it's basically everything from the past 2 weeks if you've missed something. But it's going to take me a little while to send it to each of you, especially if your name is at the bottom of the alphabet, like Olivia, you're the last one on my list. It might take me a while to get to your message. So just keep in mind that I got to go down the list of 23 kids and send each of you guys your missing assignments. But I will have that done before I leave school today, hopefully at 3. So look for those, and then those are going to all be due by Sunday. Okay. Now, yesterday, I'm going to share my screen. Yesterday, we talked about thermal energy, right? And we had, under science in Google Classroom, we had a PowerPoint about thermal energy and then a Google form. We kind of went really quick through it, so it's okay if you didn't finish or do the quiz yet, because I said we would talk about it a little bit more today. So what we're going to do is watch a YouTube video that I found that I think explains the type of heat transfer, thermal energy, and how it transfers through things with conduction, convection, and radiation. It explains it pretty well. So we're going to watch this video, and then it's going to be your responsibility after this lesson to go back and make sure you finish that thermal energy quiz. Okay, does that sound good? Okay, and keep in mind that it doesn't matter how many times you take the quiz. I'm just going to take your first grade. So some of you guys that took it like 7 or 8 times, still going to take your first grade. Sorry. So there's no need to go back and redo it unless I say like, hey, you should go back and redo this assignment. Okay? So let's go ahead and, well, your microphone's already off. So keep your mics off. Let's watch this video about thermal energy, and it explains it pretty well. So here we go.
Let's talk about heat transfer. What we're really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the Earth, up in the atmosphere, or even out in space. Heat transfer occurs really in 3 ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. This is heat transfer as a result of molecular contact. The best way to understand conduction is by thinking about an example. So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that that spoon is going to heat up, and not just the part of the spoon that's over the match, but rather the spoon as a whole. And the reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from one to the next, to the next, to the next, until the entire spoon has warmed up. That heat has transferred throughout the entire material. Conduction is going to happen most effectively in solid materials. But let's not forget about convection and radiation. Let's look at convection. This is heat transfer through or as a result of density differences. Again, let's grab that match and let's think about this for a minute. I think we all know it's probably not the best idea to hold your hand above an open flame like this, and that's because a lot of the heat energy generated by that flame is going to rise. That is purely because of the process of convection. You see, what's happening is the flame is causing the air to expand. And when it expands, it becomes less dense than the surrounding air and therefore floats upwards. And with it goes some of that heat energy. That's what convection is all about. And this is going to occur most effectively within liquids and gases. Finally, let's think about radiation. Radiation is heat transfer by wave motion. Let's pull that flame up one more time. I think we know that because of convection, is going to rise, but it's also going to travel outwards in the form of waves of energy, electromagnetic waves. And that's the third type of heat transfer. Radiation is really interesting in that it doesn't need a material for it to travel. So this can occur out in open, empty space. In fact, this is how energy travels from Earth's sun to the surface of the Earth. And so if we look back, we have our three types of heat transfer: conduction, convection, and radiation. And it's important to know the key word that goes with each one. For convection, it's going to be density differences. For conduction, it's going to be contact. For radiation, it's going to be waves. We can sum all three types of heat transfer up in one diagram by looking at something as simple as a campfire. Imagine that you're camping and you hold a pot of water or stew above that flame. Well, right now in this one picture, we are seeing all three types of heat transfer take place. There's conduction happening as the flame is transferring energy directly to and throughout the pot as a result of molecular contact. Additionally, there's convection as heat from both the boiling pot and the flame itself is rising up as a result of density differences. And finally, there's radiation occurring all around the campfire as energy travels away from the flame in the form of electromagnetic waves. And that's a quick look at heat transfer.
Is anybody else curious what that video is? Because I kind of am. It's COVID-19 healing the earth.
I am.
I might watch that later. You guys can go look it up on your own. Sorry.
I am.
Good, me too.
I'm
So that that video that I just played is on Schoology under today's folder. So you would go to Science, Week 4, Friday. So if you need that video again, that's where it is. But it's there if you need it. So now on your own, not right now, but after science is over, if you have not taken that thermal energy quiz from yesterday, that would be when you go and do that. Okay? But we're actually just going to move straight on into the final thing we're doing this week for science. And it's kind of an overview of all the different forms of energy. So on Google Classroom, you should have, under science, another little quiz. I know, sorry, there's a lot of quizzes, but usually we can do like these things in class and we don't have to take a quiz after quiz after quiz, but there's not really any other way to do an activity and so that I can see what you're learning through science without taking the quiz. So sorry, we're going to take a lot of those. Not much I can do about it. But our let's open up the quiz first, the forms of energy brain pop quiz, and let's just look at the questions it asks so that we're familiar with them, because I'm going to play the video, and just like we've talked about with brain pop, it's a video that you can't go back and watch yourself because it's a subscription. So I'm going to play it twice. So we're going to go through the questions it's asking, and then I'm going to play the video once. I'm going to give you about 3 or 4 minutes to get as many answers as you can, and then I'm going to play it one more time so that you can watch it again and see if you got a new answer for a different question, or if you're like, oh wait, I got that one wrong, let me change it. Okay, that makes sense? That's going to be what we're doing for the rest of science today. Sound good? Alrighty, so let's look at these questions. The first one is your first and last name. Put your name on it. Next one, what is energy? Choose the best answer. Okay, so you're looking for what is energy. Number 2 says, which of these objects has kinetic energy, which we talked about on Tuesday? Wednesday? One of the two. Kinetic energy. The next one, what is the difference between kinetic energy and potential energy? We also did a whole Venn diagram about kinetic and potential energy, so that might help a little bit if you want to go back and look at that PowerPoint. You can use any resources that I've given you as well. They're all in the science folder on Schoology, so you can go use any PowerPoints too. Next one says, which of the following objects has the most potential energy? So we think about what potential energy is, which one of these is going to have the most. Next one. which of the following terms is synonymous with potential energy? Now, what does the word synonymous mean? Any ideas? Synonymous. Any ideas? What about the word synonym? What does synonym mean?
Two words that are similar.
Good. So we're looking for, the answer here would be you're looking for something that is the most similar to potential energy. If we were to rename potential energy, which one of these would make the most sense? So it's a word that is similar to potential energy. Next one. What would happen if you didn't have chemical energy in your body? So that one's probably in the video. We haven't really talked about that, so that one's probably directly from the video. Next one. What is the primary source of all light energy on Earth? Again, we didn't talk too much about that one, so be careful attention on the video. Next one. Which of the following is an opinion about energy? So fact versus opinion. Which one of these is an opinion? Someone said, oh, I think this might be this, versus this is a fact. Okay. Our next one. What do wind and moving water have in common? That's probably directly from the video as well. And finally, how is nuclear energy released? So how does nuclear energy even happen? All right. So what we're going to do, you can have this open in a separate tab than the meet. I'm going to play the video for you, and then you can answer them as we go. I will play the video twice. Okay, are we ready? Okay. Can you guys see this? See the screen? Oops, oh, I gotta log in.
Yeah.
Alrighty, I'm gonna make it bigger, turn on the captions, and here we go. It's only 1 minute and 52 seconds, so pay close attention. Here we go.
Okay, just relax and keep your eye on the target. Well, that was closer than last time. Dear Tim and Moby, what is energy? From Lily. Energy is what makes matter move or change. It's the ability to do work. When the bow is stretched like that, it has potential or stored energy. We know that as soon as Moby releases the bow, that stored energy will be released as motion. The potential energy will transfer to the arrow. The arrow moving through the air has kinetic energy. That's the energy of motion. Not bad, you hit the target this time. Well, the bow does work on the arrow when you release it. And the arrow does work on the target when it hits. Energy comes in a bunch of different forms. There's chemical energy stored in food that your body uses to walk, run, and lift things. Power plants and batteries provide us with electrical energy. The sun is our major source of light energy. Wind, moving water, airplanes, and sound waves all have mechanical energy. Vibrating atoms cause heat, and that makes thermal energy. Nuclear energy is released from inside atoms when they are broken apart or fused together. Nice shot. Hey, you're becoming a pro at this. No way. There's no way I'm letting you shoot this apple off my head. Forget it.
Okay, that's kind of a quick one. I'm gonna give you guys, let's go with 3 minutes to see what answers you can get on your quiz, and then I'll play it again. And then if we need it a third time, I'll play it a third time. I got no problem with that. You guys want some music? And or. That looks kind of boring. There we go.
It sounds glitchy.
Sorry, there's not much I can do about that. It's just internet connections. Sorry. Oh, excuse me. I know.
I'm ready.
Okay. We're gonna wait for the song to end and then I'll play the video again.
Okay.
Alrighty. So, I'm gonna pause this. Don't need that. We're gonna play the video another time. Do you guys have some questions in mind that you're like, okay, I'm gonna look for that answer in the video this time?
Miss Jones, we're gonna be logging out. I'm gonna be
Sure.
logging out because lunch is almost.
Okay, that's fine. Just try and finish up that quiz, okay? Before you leave
Okay.
today. All right.
Okay.
Okay, I'm gonna go play the video again. And try and catch the answers that you missed this time.
Okay, just relax and keep your eye on the target. Well, that was closer than last time. Dear Tim and Moby, what is energy? From Lily. Energy is what makes matter move or change. It's the ability to do work. When the bow is stretched like that, it has potential or stored energy. We know that as soon as Moby releases the bow, that stored energy will be released as motion. The potential energy will transfer to the arrow. The arrow moving through the air has kinetic energy. That's the energy of motion. Not bad, you hit the target this time. Well, the bow does work on the arrow when you release it. And the arrow does work on the target when it hits. Energy comes in a bunch of different forms. There's chemical energy stored in food that your body uses to walk, run, and lift things. Power plants and batteries provide us with electrical energy. The sun is our major source of light energy.
Wind, moving water, airplanes, and sound waves all have mechanical energy. Vibrating atoms cause heat, and that makes thermal energy. Nuclear energy is released from inside atoms when they are broken apart or fused together. Nice shot. Hey, you're becoming a pro at this. No way. There's no way I'm letting you shoot this apple off my head. Forget it.
All right, so there's that second one. Also, off of that last part, with the shooting the apple off the head, when we get to go on our camp out this year, they always have a bow and arrow station where you can practice archery, and I'm pretty good at that. So you guys can challenge me if we get to go. I'll beat you guys at archery. Just saying. Now, go ahead and take another 2 or 3 minutes, finish up that quiz. Is there anybody that might need it one more time? If so, we can totally play it again. But if you are done and you finished up that quiz, you're more than welcome to head out, and I will see you guys on Monday. I'll send you your list of missing assignments so that you have it. But if you finished up that quiz, you're good to go, and I will see you guys on Monday morning, 8:30 Monday morning for ELA.
Bye, Miss Jones.
Bye, guys.
Bye.
Bye.